Hello, welcome to Group 7's presentation on designing an AWS solution for a medical company. My name is Alexander Bose, and I will be joined by Rianli Pineda and Salman Al-Samiri. In this presentation, we'll discuss a number of topics, such as what is an Amazon Web Service, who our current customer is, the services we provide to our customer through AWS, as well as conclusion, which will recap what has been discussed here today. To begin, I will discuss computing models, specifically two computing models, which are infrastructure as hardware and infrastructure as software. I will highlight the differences between these two computing models and explain why one may be a superior solution when designing your computing environment. To begin, we'll discuss infrastructure as hardware, which is a traditional computing model. It places emphasis on hardware as the main delivery method of the computing model. It comes with a number of problems, though, due to its emphasis on hardware, such as being costly on space, staff, and physical security. This means that a business has the burden of having appropriate space and paying for staff and 24-hour security for its computer systems. There is also a long hardware procurement cycle, meaning it can be timely for a business to actually acquire all of the hardware that it needs to grow or start its business. There are also theoretical peaks or provisions of capacity on these hardware systems, meaning there may be upper limits for a business on how much hardware it can have at a given time. In contrast, there exists infrastructure as software, which is more flexible, unlike hardware, as it shrinks and grows resources to suit its needs. It also offers elastic scaling of resources, which automatically utilizes certain resources when needed, rather than having to manually apply them. It allows for quick, cost-effective change, as it is entirely software-based and removes the need for any hardware that needs to be maintained, delivered, or altered. And it eliminates the heavy burden of lifting, as there is no physical hardware that needs to be lifted. So, what is Amazon Web Services? Amazon Web Services provides on-demand cloud computing services and infrastructure as software. It is an on-demand, cost-effective cloud solution that is delivered by a third party to a business and abstracts the technical implementations of a cloud solution. AWS offers software as a service to customers and removes the need for users to focus on anything but the services that they are delivering. This brings us to our current customer, a medical company. A medical company is a startup software as a service company that has created a medical social network that is used by patients and doctors alike. Currently, it has an environment heavily dependent on hardware that is more in line with infrastructure as hardware, as their computer model, and it wishes to transition to a cloud-based environment, which will be achieved using AWS services. A medical company's current environment consists of a three-tier structure. It consists of a web tier, a database tier, and an application tier. The web tier consists of two physical servers, which are two CPUs with 4 GB of memory. It utilizes Microsoft Windows 2016 base with Internet Information Services and high availability proxy load balancer used to balance traffic between the web servers. The database tier consists of one physical server that has 8 CPUs, 32 GB of memory, and 5 TB of storage. It also runs SQL Server Standard Edition with Microsoft Windows 2016 base. Database administrators can access and manage the database but no relational database management system or advanced configuration is required. The application tier consists of 2 physical servers, which are 4 CPUs with 16 GB of memory, the Microsoft Windows 2016 base with Internet Information Services, and high availability proxy load balancer used to balance traffic between the application servers. We'll now go on to the new architecture that will be implemented using AWS. It is a cloud-based solution which consists of two regions. The first being in EU West 1, which is located in Ireland, and the second being in EU East 1, which is located in North Virginia. Within each region, there is a VPC, such as VPC EU and VPC US. It is a 3-tier system as well, which consists of a web tier, application tier, and a database tier. Inside each VPC, there is 2 availability zones. There consists of availability zone A, availability zone B, availability zone Z, and availability zone C. Within these availability zones, the web and application tiers are identified, and the appropriate subnets, such as public subnets for the web tier, are associated with the web tier groups, as well as the application tiers, which use private subnets, are associated with the application tier groups. There also exist auto-scaling groups and elastic load balancers. Some of the potential AWS services which will be used to deliver this architecture include Amazon EC2, which is responsible for the instances that will be created for this, as well as the VPCs that were specified using Amazon VPC. Amazon S3 is also responsible for delivering the Amazon S3, which will be used for Amazon S3 buckets, Amazon RDS, which is responsible for the databases, Amazon Route 53, which is a highly available and scalable cloud DNS web service, Amazon IAM, which is responsible for the users and roles that will be created for this architecture, Amazon Chime, which is a communications service that can be used inside the business, the Amazon Shield, which is a distributed denial of service that safeguards the applications, and Amazon EBS. I will now hand over to Rhian Lee.
So there are 3 groups and 1 role in the account of the medical company. There is a system administrator group, and they have the most control. Examples of system administrators are John and Mary. The database administrator is the administrator for all the database related tasks, and Anna and Bob are examples. There's a monitoring group which monitor Amazon resources such as EC2, S3, and RDS. Joe, Sarah, Mike, and Jack are part of the monitoring group. And the My App role is a role created that allows for full access to all buckets through AWS Management Console. A role is an IAM identity that you can create in your account that has specific permissions. They're similar to IAM users since they have permission policies that determine what it can and cannot do in AWS. But the main difference is that it is not uniquely associated with a single person. In other words, it is assumable by anyone who needs it. So both administrator groups have programmatic access and AWS management permissions. System administrator has system administrator console access, and the reason for that is quite clear. Database administrator has Amazon RDS full access and Amazon RDS data full access, console access. These administrators have full access to the relational database service, since that is the nature of being an administrator. The monitoring group has only read-only access to EC2, S3, and RDS, since they shouldn't be allowed to modify them. And I already explained the MyApp role in the previous slide. Alright, so here are some requirements to be discussed. So the first one is to do with passwords, and it should be at least 8 characters and have 1 uppercase, 1 lowercase, and a special character and a number. So you just go to IAM, select account settings, update the password policy, then select the corresponding requirements, save the new password policy. The second requirement also has to do with passwords, so it's about the fact that the passwords have to change every 90 days and ensure that the previous 3 passwords can't be used again. So while updating the password policy, check the boxes for enable password expiration, select 90 days, check prevent password reuse, and select 3 password remembered, and then save the new password policy. So all administrators require programmatic access. So when creating a user, select programmatic access and AWS Management Console access. Assign the user to a group with an administrator access policy. Administrators sign in to the AWS Management Console requires the use of virtual MFA. So in the specific users page, select credentials and then go to assigned MFA device and then select virtual MFA device. Okay. So each region would have a certain number of networks and IP addresses. Virtual Private Cloud 1 is in Europe and it's for developers. It has 4 subnets and the availability zones are A and B. And this is because there are private and public ones for each availability zone. The CIDR ranges are from 10.0.0./24 to 10.0.30/24, and the second virtual private cloud is in the US, and it's for testing purposes. It also has 4 subnets like in Virtual Private Cloud 1 for similar reasons, and the availability zones are C and D. The CIDR ranges are from 10.0.40/24 to 10.0.70/24. Here are the development subnets in detail. All of them are in the EU West 1. Public subnet EU W1 is in the availability zone of EU West 1A and has a subnet address of 10.0.0./24. Private subnet EU W1 is similar, but it's private and the address is 10.0.10/24. Public subnet EU W2 is in the availability zone of EU West 1B and has a subnet address of 10.0.20/24. Private subnet EU W2 is similar, but it's private and the address is 10.0.30/24. These subnets are for network and security testing, and this is very important when dealing with IT resources. Public subnet US EU1 is in the availability zone of US East 1C and has a subnet address of 10.0.40/24. Private subnet US E1 is similar but is private and the address is 10.0.50/24. Public subnet US E2 is in the availability zone of US East 1D and has a subnet address of 10.0.60/24. Private subnet US E2 is similar but it's private and the address is 10.0.70/24. Now I'll hand over the presentation to Salman.
Hello, I'll talk about the web application and database tier. These three tiers are known as the three-tier architecture, which is a classic type of architecture that is normally divided into three kinds of logic: interface, business, and database logic. The web tier and app tier are known as the business logic, while the interface public instances are the public instances that the user access from toward the application via the web tier. The web tier will be assisting in the access to the app tier with a small size that only need to organize and allocate using the elastic beanstalk and load balancers to access the application tiers, which is require a more data storage and a bigger instance size. And the database require much larger because it will be storing all, if not most, of the memory. So, moving on, the web application tier are having their own elastic load balancers, because unlike this database tier, it does not. The web tier and app tier requires the user to answer the user's requests. So the web tier elastic load balancer will be allowing the internet gateway to have the data be accessed from anywhere, while the web tier application will be only accepting any data that got in through the web tier. The web tier will be taking HTTPS requests from port 443 and transforming them into a suitable 8080 TCP port so that it would be usable in the private subnets for the app tier. The web tier, app tier, and database tier have their own security group and rules that specify how it's accessed and from where and what kind of data are used and accessed and passed from it. So moving on to the next slide. The business continuity of the web and app tier will be focusing on a base operating system for the instances that being made via the auto-scaling. So the configuration will be set to be a T3 medium for the web tier and a T3 X large for the app tier. A smaller size for the web tier, while the app tier require much more size to be used. The configuration will be set for both of them so that whenever the system needs more instances or data, the elastic load balancer will be able to handle more and swap the users from a non-used instance, or more to be more specific, an instance that is bugged or malfunctioning, to a instance that is usable to fulfill the user needs. So moving on to the next slide. The instances will be range from 2 to 4 instances for each tier, for each availability zone to be more precise. And each of them will be having their own auto-scaling to focus on each tier, and that will be handled by each elastic load balancer that will target the instance and move from one instance to another if it failed, and the auto-scaling will be telling the elastic load balancer what instance it just made. with a specific name and the value of the name. So moving on, any company or any business would need an auditing to administer over their services and businesses and oversee the work process. Amazon IAM makes sure that your users, groups, and roles and policies are secure, authenticated with a specific rule that would fit the company needs or the general authentication rules. Amazon Cloud Trial, Amazon CloudWatch, and Amazon CloudWatch Alarm would be monitoring the process ups and downs, and if case anything needs to be alerted to the management or the admins or whoever is responsible for a specific service, the CloudWatch Alarm will be checking the CloudWatch, and whenever it noticed something wrong or something get triggered, it will soon send it to the user to be notified via e-notification service like the SNS service on Amazon. And finally, the conclusion. The AWS Console Management is an excellent service for companies such as the medical company we're talking about in our project to be transitioned into a cloud-based environment, as it allows the company to minimize their funding spend, and it's quite friendly to customers who are not necessarily experts in technology or proficient at coding. AWS is a well-thought packages with many services that is suitable for most needs or any need that the user could need in order to have a good business, and it's quite secure with many security services. Premium and standard services are as efficient as it could be. It's quite cost-efficient solution that it would show you and help you plan to minimize your cost, and if you even need to increase your cost, it makes it easier to manage the increase of cost for a limited time if needed, for such as busy time or emergencies. The AWS is well equipped for timed increases or changes in the cost process that would be set via the AWS system. Thank you, and hope to see you at another time. Stay safe. Goodbye.